So let's start with this thread programming today. I see people used to ask me eagerly about the thread programming, but I don't see them in the class. So people show eagerness in only completing the topics, but they don't attend the classes. That is a real problem. Yes. Okay. Fine. So Java is not for lazy people, to be frank. It's only for hard workers. Yes. Lazy people cannot survive in Java. At some point of time, they will realize it. Yes. Okay. So thread programming. Um, sorry, thread programming. So we'll start with thread programming. Java, you'll find that it is based on threads. Yes. So mainly, you'll find that in Java, everywhere you'll find threads. Yes. So it supports the thread programming, and it is also based on thread programming itself. Now, before we start with thread programming, first of all, it is also it's my duty to make you people understand what is a process. So you might have heard about this term a lot, process. So what is a process actually? What is a process? A process means you'll find that it is a program. Yes, process is a program in execution. Yes. Process is a program in execution. Yes. So program is just set of instructions. Now when that instructions are executed, you know, when the instructions execute, you need certain resources. Okay. So a process, you'll find that it is a program in execution with some resources allocated to it to execute those instructions. For every process, set of resources are allocated. The responsibility of a process is to execute the instructions. Sorry. For a program, you can have one or more than one process also. It depends. So, you know, you'll find that every program or every application, the instructions will be executed by a process itself. Yes, the instructions are executed by the process itself. So, you see, now in this operating system as of now, you'll have processes which are running. Process is singular, processes means plural. Yes. So you have almost 70 processes here. As of now, you see, you got 70 processes. Yes. You know, each process which you got here, these are the list of processes which you can see. Each process, you will find that it is executed by the, sorry, each process, it executes the instructions of an application. Each process executes the instructions of an application. Okay, yes. So for a for an application, you can have more than one process also. For an application, you can have more than one process also. For example, you know, for this GoToMeeting application, you got one, two, three, four, five processes are there for GoToMeeting application. For Dropbox, you got one process. Okay, so this way for every application you'll have a process. For Tomcat server, you got one process. For 7 version, Tomcat 7 version, there is one process. Tomcat 8 version, there is another process, and so on like that. So you know, you'll find that we got 70 processes which are currently listed down here, which you can think of them as executing. Yes. Now, what are the resources which are needed for the process to execute? Let's see. Okay, people who have just joined, I'm talking about thread programming here. Okay, yes. And as part of it, I've just started with the process. So process is program in execution. And you know, for a process, you need set of resources, as I told you people. A process needs set of resources. So what are the resources here? So that resources, they include memory, input IO devices, input output devices, and most importantly, what is it? CPU, or you need processor. Okay, yes. Most importantly, you need a processor as well here. Yes. So sorry. Here you will find that a process will need all these resources. A part of memory is allocated for the process, and it will be using IO devices if needed, if necessary. And you see, especially this processor, you will find that this is one of the resources which is very scarce. Um, you will find that the processor, you'll have a very limited number of processors in a machine. So the ratio will be always 1 is to 20, 1 is to 30 and all. So set of processors will be sharing the same processor. Even though it is a, you know, dual core, octa core, whatever it is, you see, always the ratio will be 1 is to 40, 1 is to 50, 1 is to 70, depends. Okay. So now every process in order to execute, definitely it needs processor. Every process in order to execute, definitely it needs processor. Yes, definitely it is going to need processor. So now only when the processor is allocated to the process, a process can execute the instructions. Now you see we have 70 processes here. can I say that the processor can be assigned to all the processes at once? Can we assign, or not be in the sense, your operating system, will it be able to assign the processor to all the processes at once? No, at once it is not possible. Okay, so a processor cannot be assigned to more than one process at a time. It can be only assigned to one process at any given point of time. Please remember this point and make a note of it if you want. At any given point of time, a processor can be assigned to only one process, not more than one process. Yes, good. So, here, that means you have 70 processes. At any given point of time, you see, out of 70, only one process is allocated the processor, and it is executing. Okay, yes. You know, now generally we get an impression that multiple processes are executing at once. That means multiple applications are executing at once. You see, you got GoToMeeting, Notepad, we got, you know, what else? Dropbox. So you'll see a lot of applications and the processes associated to it, as if generally we think that all these processes are executing at once parallelly. All these applications are executing parallelly, I can say. But that is not the case. You know, as of now, we get an impression that as if all these applications are executing at once. That means the processes which are associated to this application, they are executing at once. But that is not the case. You will find that at any given point of time, only one application will be executing. Okay? Yes. Only one application will be executing. Yes. So, but generally we get an impression that more than one process is executing at once, right? Because the speed at which this processes, the speed at which this processes are executing, for few human beings, you see, it is difficult to identify that they're switching here. Generally processes will be switching, so they won't execute at once. You will find that the process will be executing one after the other. Okay, processes will be executing one after the other here. Yes, processes will be executing one after the other, but we get an impression that all the processors are executing at once. So because of the speed at which they are executing, the speed at which they switch, okay, that gives an impression that generally all these processes are executing at once. Yes. Just a minute. Saurav, actually, sorry, Saurav, I'm sorry. So you had issue with the Dropbox, right? So, but first of all, I'm not sure you have given the permission to which folders of your Dropbox. You just check once, okay? And let me know.
Mahesh, the thing is like I'm not able to delete the contents actually, like as they are shared by you.
No, Shravan,
I
I'm
like
not talking to you. Just a minute, please. Yeah, I'll
okay.
talk to you. Saurav, just mail me which folders, Dropbox folders have access. I give access to you, okay? So just mail me. Yeah,
Okay,
yeah, sure. Because you have been
sure,
given access
sure.
to multiple folders, you know that multiple Dropbox folders.
Mm-hmm.
To make sure that
Right.
you mail me the details about it so that I can just remove you from those folders and give you only access to one folder. Okay.
Okay, sure.
Okay, fine. Shravanti, yes. So coming to your issue, Shravanti. So the thing is, yes, Dropbox become generally the space for you people. It might be limited because you might have not given, you know, any. You might have not bought any subscriptions. So you may not have subscribed for a Dropbox folder. That means you might have not bought any space on Dropbox. So let me do one thing. Yeah, and I don't give the permission to everyone to delete the folders because if I give the permission to delete the files, then it will be a big mess up because people
Yeah.
immediately once I upload it, they may delete at any point of time, and this happened earlier. So once I uploaded, someone used to delete it, and I used to get mails flooding saying that okay, the file is deleted. Please upload it again. So it was like playing Mickey Mouse. So that was really bad experience for me. So always
So what can be the
what I
alternative for
can
this one?
what don't need to worry. Just make sure that all of you copy your records to your local drive first of all, so that I can delete the old records and you will be able to access the fresh records. Okay, that is the solution. That's it. Make sure that always you copy the old records. Please, don't show any lenience in this regard. Always make sure that you copy the records as soon as possible to your local drive from the Dropbox folder. Okay, so that I can upload fresh records. Actually, I've uploaded it, but you might not be able to see that because of space issue.
Yeah, as my Dropbox is full, I'm not able to see
That
the
is what
latest
happened.
videos. That's
Make
the
sure that
problem.
you upload it. Sorry, you try to copy them, all of you. You know what happens again? Immediately, if I drop it, if I delete them without giving any notice, what happens? People will again say that okay, I didn't copy them. Even this is a problem. So they say that okay, please give me some time, or I didn't copy them. Please upload it again. The same issue again. So that's the reason why I'm announcing it in the class now. Please make sure that you copy them. So I'm going to delete them. Please, after deleting, don't ask me. Yes, I'm not responsible.
Yeah, Mahesh, you just
Make
do
sure that
one thing. You just keep a deadline for everyone so that they'll
that's
copy
it.
before
By
that date.
today or tomorrow, please do that. So I'll delete it. Okay. Yes. Make sure that all of you copy the records as soon as possible, so that I can delete them. Yes. If anyone has got space issues, especially, please make sure that you copy them. Okay. Yes. Let's continue with this discussion. Yeah. So let's continue with this. Um, yeah. Sorry. So now you see, at any given point of time, as I told you people, you'll find that you'll have only one process executing. All other process will be waiting for the processor. Which process will be executing? Whichever the process is given the processor, that particular process will be executing, and all other processes will be waiting for the processor, okay, to be allocated to them. Yes. So generally, the operating system will take care of allocating the processor to the processes. Okay. Generally, what happens is the operating system will take care of allocating the processor to the processes. And there are different algorithms, scheduling algorithms, we say, which are available for this. It depends on the operating system, which operating system you're using. So we say there it is called as CPU scheduling algorithms. Sorry. I'm sorry. Excuse me. CPU scheduling algorithms. So if you people are interested, you can go through them, but I'm not going to talk about them in the class. So we don't need to uh, consider about this one. But if you got interest, you need to know how that processor will be assigned to the process. So on what basis, how it is allocated, you can check once. Okay. Yes. CPU scheduling algorithms, I can say. Okay. Yes. Yes. So generally there are several CPU scheduling algorithms. Like for example, you got round robin. I'll just brief you people on this round robin. In round robin CPU scheduling algorithm, you know what happens? So it will be like first come first serve. So whichever processes first arrives for the processor, that process will be given the processor, and all other process which arrive next for this processor, they will be waiting in the queue. They will be waiting in the queue, and this processor, you know how. This processor, you will find that it will be allocated for a process for a particular time period. Yes, that is time slot. So for every process, a time slice will be given. That means for a dedicated amount of time will be allocated for each processor. Okay. Yes. So yes, you'll find that here, once that time slot which is allocated for that processor, for that process is finished, what happens? You'll find that the next process will be, which is in the queue, will be given that processor, will be allocated, next process will be allocated the processor so that it can execute. Okay. Yes. So for suppose, let's say the time slice which is given for this process, that was not enough for the process to execute the instructions. Then what? Yes. In that case, you will find that, yeah, for suppose the time slice or the time period which was given for that process, for a period of time that processor will be allocated to the process, right? So during this time, what if the process is not able to execute all the instructions? So in that case, if the process is not yet done with the execution, I can say, okay, the processor is assigned to the process, right? And if process is not able to execute all the instructions, in that case, the process will go back to the queue, and again it will wait for its turn. Okay, again it will wait for its turn. This is round robin. So you see, once the processor is allocated, it has to execute the instructions, right? And for suppose if the process is not completely executed, so but the time has over, so again it has to go back and wait for its turn. Meanwhile, the processor will be assigned to other processor. Okay. Yes. Sorry, other processor will be allocated to other process. So this way you'll find that the processor will be assigned to each process for a period of time. We say it is a time slice. Okay. Yes. So during that time slice, that process has to execute the instructions. If it is unable to complete it, again it has to go back to the queue and wait for its turn. So this is one of the scheduling algorithms. I can say we have many such scheduling algorithms which you will find. Okay. Yes. Fine. So the switching between the processes will take place always. Okay. Yes. The switching is very fast that we can't really detect it. Yes. Okay. Yes. Fine. Next, here, why we are talking about the processor and process in the thread programming. Okay, I've spent a lot of time here with this regard, because threads and processes, they are related. You know how their threads and processes are related? I'll tell you people. A thread, I can say that thread is a sub process, or we say thread is a lightweight process. Lightweight process. You'll find that in a process you will have set of threads. In a process you'll have set of threads. In a thread, in a process, you'll find that you'll have set of threads. I'll show you people. Just a minute. Options, view, select columns, threads. Okay. Now you see, for each process, you have threads. For the first process, how many threads you have? Can you see this threads column? Have you noticed it? You have 104 threads. In the first process, how many threads are there? 104. In the second process, you see we got 70 threads. Okay. And in the third process, you got 33 threads. Yes. Okay. Yeah. So you see the memory, how much it is allocated, even that details you got it here. So the threads which are part of this process, they are actually responsible for executing the task which is assigned to this process. The threads, they are going to execute the task which is assigned to this process here. Yes. Okay. So that's the reason why we say a thread is a sub process. What is thread? It's a sub process. It is part of a process and it is threads are mainly responsible for executing the task which is assigned to the process. Yes. Okay, fine. You know, even the threads, they're similar to the process. So the threads, in order to execute the instructions, they need the memory. Definitely, they need memory. Okay, yes. Sorry, they need memory. Not only memory, most importantly, they need processor. And threads also, they share the processor. The way the processors share the processor. Similarly, threads also will be sharing the processor. Similarly, threads also will be sharing the processor here. Yes. Okay. Yeah. Fine. So now, how is Java related to this threads? You will find that in Java we got very good support for creating the threads. You know, working with the threads. So it will be interesting. This kind of programming you will find that very interesting. Okay. Yes. Let me show you people. You know, each and every program so far which we have executed, you'll find that they're based on threads itself. Yes. So for suppose you see we have this program, right? Just a second, please. You know what? For suppose we have this method. Whenever we run this program, you know that the program starts execution from the main method, right? So, you know, who executes the instructions which are defined in this main method? Who is responsible for executing the instructions which are defined in the main method? The thread itself. Okay, thread. You know what happens when we run this program? Your JVM, we start the JVM. Internally, what happens? The JVM will be will be invoked. The JVM will start. Yes, and you know you will find that the JVM will be responsible for executing the instructions which are defined in this method. Sorry, right? But that is what I used to say always. But internally, you know what happens? The JVM, when it is invoked, JVM in turn, it creates a thread. It creates a thread and it names it as main. A main thread will be created. It creates a thread with the name main, and you know, to this main thread it will assign the task of executing the main method. It will assign the task of executing the main method here. Yes, to the main thread it will assign the task of executing. Just a minute, please. Just a minute. Yeah, I'm sorry. So, you know, as I told you people, when we run this program, you just a minute, just a minute. Sorry. My son, 2 years, he's old. He's 2 years old. He's almost invincible. He's uncontrollable, I can say. Invincible. He listens to no one. Yes. And he never sits at one place. Okay. Sorry. So, yeah. So when the program starts execution, you will find that the JVM, what it does is, first of all, it will create a thread. Name of that thread will be main. And to this thread, it will assign the task of executing the main method. Okay. Main thread is different and main method is different. So always we define a main method, right? And to execute this main method, what happens? The processor, sorry, the JVM will create a thread. Okay, will create a thread, and it will assign the task to that thread. So who's executing the instructions defined in this main method? Main thread. That's right. Main thread. Okay. Okay. Now, can we access this thread? Is there any option for us to access this thread which is executing the main method? I can say yes, of course, definitely. Let me show you people. So I'll do this. Just I'll create a for each loop to read the elements from that list. Here, if you want to access the thread which is currently executing this method, we have that option. We can do that. Okay. You know, for that, we have to use a class called as thread. There is a class called as thread in Java. There is a class called as thread in Java. We can use this class called as thread to access that thread. Okay, to work with the threads, I can say. Just a second, please. Okay, so one thing here before we start looking at this thread, Java is object oriented. Java is object oriented. In Java, everything is represented as an object. Even threads are also objects here. Okay, even threads are also objects. Yes. Okay, even threads are also objects. So for that thread objects, you have this class. Yes. The thread objects are represented using this thread class. Okay. Yes. Fine. So in the thread class, there is a static method called as current thread. You know, if you call this method current thread method, static method called as current thread, this method, it returns the object reference of the thread which is currently executing this method. You'll get the object reference of the thread which is currently executing this method. Which method? The main method here. Okay. Yes. Yeah. So what the current thread method does, all of you please make a note of it. It's a very useful method, handy method. Whenever you want to obtain the object reference of the thread, okay, if you want to obtain object reference of the thread which is currently executing this method, then you can call this method current thread. Okay. Yes. So current thread method returns the object reference of the thread which is currently executing this method. Once again, I'll repeat it. The current thread method, what it does, it returns the object reference of the thread which is currently executing this method, which is currently executing this method. Yes. Okay. Now, I'll try to print the thread name. For the thread, we got a name, right? Let's print the thread name. If you want to print the thread name, then you can call this get name method. You can call the get name method. Yes. And we can also play around with this thread. For suppose, if you want, you can make this thread sleep for a while. You can make this thread sleep for a while. You have static method called sleep. Call this method, and you can specify the time period. How long you want this thread to sleep. This method throws an exception, checked exception, interrupted exception. Yes. So you see, using the sleep method, what we are doing, we are instructing the thread which is currently executing this method to sleep for a while. Sleep means pause for a while. So when the thread is in sleep mode, so I can say it is paused. Pause means it won't execute. It will wait for a while. It will simply sit idle. How long it will sit idle? For 6,000 milliseconds. This figure, this number is in milliseconds. It will sit idle for 6,000 milliseconds. Yes. Okay. It will sit idle for 6,000 milliseconds. Yes. Got it? Yes. So that means when you run this code, first of all, okay, all these instructions will execute. First, a list object is created, elements are added. So we are obtaining the thread object reference. We are printing the name of the thread. And then you see, for a while, the thread will sit idle. That means during the time, for 6,000 milliseconds, so the thread will not execute any instructions of this method. and after that it comes out of that sleep mode, and then it prints that elements. This is the instructions which it will execute. Okay, so each and every instruction which you got here, now it is executed by the thread itself, I can say. Sorry. You see, now it prints main and waits for a while. It's still waiting. You see, and then it prints that elements. So once again, I'll show you people. You can check this. You can notice this. See thread name main, and it waits for a while, and then it prints that elements. Yes. So is it clear for you people what we did so far? Any questions in this regard? Let me know. So any questions? No, right? Okay, fine. Now you see we saw that predefined thread, the thread which was created internally, we were able to access that thread, and we are able to, you know, also instruct the thread to sleep and all, right? Now you understood that the instructions which we write here in this method, so they are executed by the main thread. Yes, they are executed by the main thread. Yes. Now we'll talk about how to create a thread. We'll see how to create our own thread, user-defined thread, I can say. Okay, we'll create our own thread, user-defined thread. I'm sorry. Let's see how to do that. We can also create our own thread, and to that thread we can assign a task. We can ask the thread to execute set of instructions. We can do that. Okay. Yes. So if you want to create your own thread, a user-defined thread, in that case, this is what you need to do. First, define a class. Define a class. You can give any name to this class you wish. I'll call it as sample thread in this case, and make this class extends thread. Make this class extends thread class. Okay. Yes. Yes. So thread class is a predefined class in Java. So where it is defined in java.lang package. So this way, by extending the predefined thread class, we can create a thread, I can say. We can create a thread. Yes. Now in this class, we can override this method here. Okay. Yes. You know, what is the purpose of creating a thread? So that we can assign some task to that thread. We can assign the task to the thread. So how will you define a task to the thread? How will you assign the task? Where you will define the task for the thread? So in order to define the task for the thread, you can override the run method here. We can override the run method. Okay. Yes. Okay. So the run method, where it is defined? In the thread class. So you're overriding it, right? So it is inherited from the thread class. The run method, it is inherited from the thread class here. Okay, yes. So now you can define any task to this thread you wish. For suppose, I'll just make this thread to execute a loop. So just making this thread to execute a loop here. That's it. Sorry. Set print I values now. So you see, now we have this thread class and we have defined the task for that thread in the run method. Now let's start the thread. So if you want to start the thread, then you call this, sorry, you instantiate that class, thread class. Instantiate the thread class. Instantiate this thread class. Okay, yes. Okay. So after instantiating the thread class, now we can give a name to this thread. You see, you got set name method. It is defined in the thread class. Use the set name method. So we'll call it a sample thread. Sample thread. Okay. So now we can start the thread. So to start the thread, call this start method. That's it. In order to start the thread, call the start method here. Okay. So that's it. Now once you start the thread, what happens? The thread, now it will execute the task which is assigned to it. Okay. So let's run this code. Okay. You see, it prints that for loop has executed. The run method, in the run method we have defined the for loop, right? And it has executed here. Yes. Okay. It will take a name, but that name will be, you know, something like thread 001 or something like that. So you can give your own name. Okay. Fine. So if you can give your own name, that would be more better, right? So this is more flexible. Yes. Okay. You see, to start the thread, we have to definitely call the start method. Okay. You have to call the start method to start the thread. Yeah. Next, you know, as of now in this program, how many threads are created in this program? When we executed this program, how many threads are created? Yes. How many threads are created? Okay, two threads. So one is main thread and the other one is sample thread, the user defined thread. You see, in the context of main thread, we are creating this sample thread here. Okay, in the context of main thread, we are creating the sample thread. Yes, two threads are created altogether. Yes. Now, for suppose, what if I want to print the name of the thread which is executing this run method? So what to do? I want to print the name of the thread which is currently executing this run method. What to do? I'm sorry. So you can call get name or no. First of all, you need the object reference of the thread. First of all, you need the object reference of this thread. So which thread is currently executing? How will you obtain the object reference of the thread which is currently executing this method? What is that method which you got? Yes. Current thread. Yes. So you need to call that method current thread. Yes. Okay. Call the current thread method. Yes. So I'll show you a shortcut. What you can do is thread dot call this current thread method, and that current thread method returns the object reference, right? On that object reference, you can call this method. Yes. Hope you people got it. Okay. So this is how you'll obtain the object reference of the thread which is currently executing a method. You can obtain the object reference of the thread which is currently executing this method here. Yes. Let's see. Here also, if you want, I'll print that the details. So thread dot current thread dot get name. Okay. Yes. So we'll run this code. I'll do one thing. Actually, I'll print this details. So main method, we'll see. So which method is executed, which thread is executed by the main method, sorry, which thread executes main method, and which thread executes run method. So we'll print the details. Okay. You see main method, main thread, run method, sample thread. So next, here, for suppose instead of calling the start method, what if I call run method directly? You see, you got run method in this class, right? What if I call the run method here directly? What happens? What do you people think? If you call the run method directly, what happens? Okay. Maybe you might be thinking in what ways to answer this question. So let me give you an idea of what I'm asking you people actually. Here, my question is mainly how many threads will be created? Actually, the sample thread at first place, will it be created or not? Will it execute or not? So what do you people think? Here in this case also, do you think the sample thread will be created? It will execute? No? Okay. So Vamshi says sample thread will not execute. Yes. Then which thread will be executing the instructions here? Which thread will execute that run method? Main thread. Main thread itself will execute the run method. That's right, exactly. Very good. Yes, that's true. You know, you have to call start method explicitly. And if you don't call the start method explicitly, your thread will not start. And if your thread if it doesn't start, that means what happens? That method which you got will be executed by the main thread itself here. Okay, we have only one thread. From the context of main thread, we are calling. From the context of main thread, we are calling that run method. So run method is also executed by that main thread itself. You see, main method is executed by main thread. Run method is also executed by that main thread itself. In both the cases, for both the methods, the thread name is printed as main. Yes. So is it clear for you people? Okay. Now I have a question for you people. For suppose, yeah, because yes, that is what the reason is. Explicitly, we have to start the thread. Otherwise, it won't start. That is what the point I want to make here. If you don't call the start method, your thread will not start execution. Okay. So if you want your thread to start execution, call the start method. Otherwise, it won't start execution. You got it. So why did we define the thread? So that it will execute the instructions, right? So if you don't start the thread will not execute and it won't execute the instructions. Yes, that won't happen then. So the purpose of defining the thread class is based. We want the thread class, we want to create a new thread and assign the task to that thread, right? So that it will execute it. So after doing all this stuff, if you don't call the start method, the thread won't start. And what is the use of creating the thread, right? Yes, fine. Now I have a question. Okay, so before that, I let me ask you people if you got any questions. Yes, any questions? Yes, that is what you know. You have answered it right. You saw that if that thread doesn't start, so which thread is executing that instructions of run method? The main thread itself, because you're calling the run method right from the main thread. So what you're doing basically, you're calling the run method from the main thread. Yes, you got the point. Okay, so you know whatever the instructions which are defined in the main method, they will be generally executed by the main thread. Okay, even if you call any methods from the main method, if you call any methods from the main method, if you call any methods from the main method, even those methods you will find that they will be executed by the main thread itself. Yes. Okay, fine. Now let's move on. I have a question for you people. Yes, what is it? The question is, what if I want to create another thread, and to that thread also I want to assign the same task? What to do? What if I want to create another thread, and to that thread also I would like to assign the same task? Yes. Okay. So that means I want to create two threads altogether which will execute the same task which is defined in this run method. So what to do? Yes, all of you, hope you got this question. So I want to create another thread, so that thread also should execute the same task. So what to do? Okay, I'll show you people. Don't worry. So in that case, now you have to instantiate the sample thread class again. Okay. So each thread will be represented by a thread object. Okay. So instantiate the sample thread class, create the sample thread class object, and call that set method. Set name method, I'm sorry. And you can give a name to that thread. Sample thread 2. And you can start this thread.
Mahesh, here now in both the cases it will take the same overridden run method.
Okay, yeah. So that means two threads will start here, and both the threads will execute the run method. Okay. Let me run this code. Now, altogether, how many threads are created? Three threads. Yes. So one is main thread. The other two threads are sample thread and sample thread 2. Yes. Now, 1, 2, 3, 4, 4. Just a minute. Yeah, because the threads now they are executing, right? So this kind of output is expected. Yes. Okay. Yes. So both the threads they will be executing right parallelly. So this is expected. Okay. Yeah, you see, you'll find that 1, 2, 3 is executed first of all by the first thread, and meanwhile in between the second thread also joined, which is also printing 1, 2, 3, 4, and last 4 is printed by that thread again. Okay.
That's what I'm saying. Like it cannot be same all the time, right? For suppose if in one case you can
Yeah,
get like
yeah.
0, 1, 2, and it
This
starts something like that.
depends. Yeah. Now you'll find that one thread may start earlier of other thread. So in between other threads may join. So output may vary from execution to execution. Yes. One after the other itself, but we get an impression, as I told you, people as if they are executing parallelly. Okay, so that the outputs here they may vary. Okay, because it affects the number of threads as it grows. So the execution allocation of that thread to the browser and all they may vary. So output also may vary. But at the end they will execute the task which is assigned to them. Okay. Hope you people got it. Yes. Not predictable. That is not predictable. So you may not get the same output. Okay. So, but yes, to some extent, yes, it is possible. Now I have a question. Okay. What is the question? I want to make the second thread to sleep, or let's say first thread to sleep. Sample thread is there now. I want the sample thread 1. Let's say I'll name it as sample thread 1. So whenever the sample thread 1 starts execution, whenever the sample thread 1 starts execution, immediately I want to instruct it to sleep. How can we do that? I want to only instruct sample thread 1 to sleep. I want to only instruct sample thread 1 to sleep. So what to do? Now both the threads will be executing this run method, right? No, we can't do that. Actually, yes, this is what the misconception is. Now you see, sleep method is a static method, right? Generally, we don't use object reference to call the sleep method. Okay, it's a static method. I'll tell you people. Now you see, the issue is now both the threads will be running this, executing this run method, right? So there is only scope to call that sleep method here, because sleep method, as I told you people, it is used to instruct the currently executing thread to sleep. Sleep method is used to instruct the currently executing method to sleep. Okay, yes. So here that means now we have to check which thread is currently executing, and accordingly you can instruct it to sleep. I can do this. Thread name, okay. So if thread name dot equals sample thread 1, then make this thread sleep, let's say for 500 milliseconds. That's it. Okay, so now this method throws a checked exception, right? So use try catch. You can't use throws here. We'll end up changing the method signature then. Okay, is it clear for you people, all of you? Now both the threads will be executing this run method. Now whichever thread name is sample thread 1 will instruct that thread to pause or sleep, I can say. Okay, yes. Yeah. Now how do you know which thread is printing these details? So I'll do one thing. So before this I values, I'll print the thread name, so that you'll understand which thread is printing the I values. We'll print the thread name. Okay, yes. Okay, so I'll use println method here, so it's better, so that each value will be printed in a separate line. You see, and one more thing I'll show you people. You see, whenever the thread starts execution, we'll print the name of that thread. So thread thread name started execution. Let's say I'll print this message, started execution. So we'll come to know which thread will start execution first. Immediately first we'll print the details of the thread which started execution of this run method, and then you see we'll check that thread name and we'll make it to sleep. And once which thread will be which thread we are instructing it to sleep here, thread 1, right? Yes. You see, so first of all, you see thread 1 started execution because we have instructed it to sleep. Now you see thread 2 has started and it continued the execution and it is printing the type values, and later on thread 1 came into picture and it is executing the instructions. Okay, so is it clear for you people, all of you? So any questions? Okay, now we saw one way of creating this thread, right? Let's see the other way of creating the thread. So we can also create a thread by implementing runnable interface. We can also create a thread by implementing runnable interface. This is the second approach, runnable interface. So in this interface, we got that run method. In this interface, we have that run method. Let's see. So I'll define a class with the name test runnable, and I'll make this class implements runnable interface, and then here you'll override that run method and define the task for the thread. Okay, so this thread is created using runnable interface, let's say. Okay, I see this is just in this class, you see, which implements runnable interface, we have only defined that task for the thread. Only we are defining the task for the thread. I can't say this is a thread class. So this class only represents the task which has to be executed by the thread. What task the thread is supposed to execute, that task is defined here in this class. Next, I will instantiate that class, test runnable class. So this class is not representing the thread object now. It only represents the task for the thread. Now you need to instantiate the thread class this way. and pass that runnable object reference. Pass that runnable class object reference here this way. Okay, and now you can name the thread. Call set name method. Let's say test thread, test one or something like this, and you can start the thread. Again, you'll use thread class here, but this way will not make your class extends thread class. Yes, we'll directly instantiate the thread class and pass that runnable object reference to this test thread to the thread class constructor. Okay, so let's run this code. So this thread is created using runnable interface. Okay, so this is the other way of creating the thread. Now there is an advantage of using this approach, I can say, over the first approach. So can you people tell me what is the advantage? Yeah, you see now this class, it doesn't extend thread class, so it implements that interface runnable. That means here you got a scope for this class to extend some other class, right? Yeah. So we got a chance to make this class extend some other class here. Yes. So this is considered as flexible approach of creating a thread. Okay, the second approach. This is also widely used approach. Okay. Yes. Fine. So this way you have two different ways of creating the thread. So anyways, both doesn't make any difference in the thread's functionality. The thread functionality will not change. Thread behavior will not change. Thread behavior or functionality will be same. The only thing is the approach which you're following is different. That's it. Yeah. So any questions? Okay, good. So I'll stop it here today. Okay. And we'll meet in the morning at 8 a.m. Central Time. So in the morning class, I'll talk about thread lifecycle, and we'll see thread synchronization, multi-threading, and communication between the threads. So it will be 4 hour session. Please make sure that you make yourself available. So we got a class morning at 8 a.m. Central Time. Okay. Yes. Sure. Test class. See what we are doing. You have to pass this runnable class object reference to the thread class constructor. Directly we are instantiating the thread class here. Okay. So any questions? Let me know. No? Okay then. So good night all of you. Let's meet tomorrow and continue discussion.